Hello students, I am Dr. Navneet Kaur, Associate Professor in EC Department of Sagar Institute and of Research and Technology College, Bhopal. Today I am taking lecture on subject digital communication. The topic of my lecture is M-ary phase shift keying system. Now in my previous lectures, I have already covered binary phase shift keying and quadrature phase shift keying system. We have seen that in binary phase shift keying, our symbol is made up of one bit. So we have two symbols, either 0 bit or 1 bit. And in case of BPSK, the phase shift is given by 2 pi divided by number of symbols, which are 2 in case of BPSK, which is given as pi or 180 degree. So in BPSK, whenever there is a change in the symbol, there is a phase shift of 180 degree. Now in QPSK, each symbol is made up of 2 successive bits. So 4 distinct symbols are formed. So whenever the symbol is changed, the phase shift is given by 2 pi divided by number of symbols, which is 2 pi divided by 4, which is given as pi by 2 or 90 degree. So whenever there is a change in the symbol, there is a phase shift of 90 degree. Now, in case of M-ary PSK system, we have m possible symbols. Now here, each symbol is made up of capital N bits, such that 2 raised to power capital N is equal to m, where n is the number of bits in one symbol and m is the total number of the symbols. Now, in M-ary PSK, whenever the symbol is changed, the phase shift is given as 2 pi divided by number of symbols, which is 2 pi by m. Now here each symbol is made up of n bits, and we know that the duration of one bit is TB. So here we will see that the duration of one symbol TS is given as capital N TB. Now, since there are m symbols, the system is known as M-ary PSK system. Now, the transmitted waveform is given by the expression ST is equal to root 2ps cos 2 pi f naught t plus phi m, where root 2ps is the voltage maximum voltage level of the carrier signal, f naught is the frequency of the carrier signal, and phi m is the phase shift whenever there is a change in the symbol. Now, this phase angle is given as 2m plus 1 divided by into pi by m, where small m is given as values 0, 1, 2 till m minus 1. So here we have total of capital M values. So whenever we have m is equal to 0, we have phase shift of pi by m. When we have m is equal to 1, we have 3 pi by m. So whenever there is a change in the symbol, the phase shift of 2 pi by m occurs. Now, this is the general expression for M-ary PSK system, which is given as root 2p cos phi m cos 2 pi f naught t minus root 2p sin phi m sin 2 pi f naught t. This equation is obtained whenever we will expand this expression cos A plus B. Now here we will get this equation. Now we will rearrange the above equation. We will multiply and divide these two by root TS. Now here we will have root PS TS, root 2 upon TS cos phi m cos 2 pi f naught t. Similarly, in second term also, we have multiplied and divided by root TS. And we have rearranged the terms and we have got this equation. Now, here we will assume phi 1t and phi 2t as two orthonormal carrier signals, where phi 1t is given by root 2 by ts cos 2 pi f naught t, whereas phi 2t is given as root 2 upon ts sin 2 pi f naught t. Now here we can see that these two orthonormal carrier vectors are orthogonal to each other and they are normalized also. So we can say that these two represents orthonormal carrier signal. Here, now we have represented phi 1t in place of this expression. So here in first term, we will get phi 1t. And in second term also, we have replaced root 2 upon ts sine term by phi 2t. So this will be the resultant equation. Now, here we can see that these two terms are orthonormal waveforms. And these orthonormal carriers forms two axes whenever we place them in signal space. Now, the signal points, they are placed on the circumference of the circle. Now, this will be shown in the figure, which will be shown in the next slide. Now, here I can explain by representing it on the signal space. Now here we can see phi 1t, which is in the direction of cos 2 pi f naught t, and phi 2t, which is a vector in the direction of sine 2 pi f naught t. Since cos and sine have a phase shift of 90 degree, here we can see sine lags cos by 90 degree. So phi 2t is lagging cos 2 pi f naught t by 90 degree. Now, whenever we have first symbol S0, S0 is represented whenever m is equal to 0. Now, if I represent m is equal to 0, I'll get term root 2 ps cos 2 pi f naught t plus this phi m, where m is equal to 0, which is represented as pi by m. That means with respect to cos, direction of cos, we have shifted clockwise by angle pi by m, which will represent the first symbol. So here we can see the first symbol, which is having phase shift of pi by m with respect to the direction of cos 2 pi f naught t. Now, when we want to represent second symbol, which is S1, here we will take m is equal to 1. So when we will replace this phi m by this expression with m is equal to 1, we will get 3 pi by m. That means now we will shift by angle 3 pi by m with respect to the direction of cos 2 pi f naught t. So which will be the expression for the second symbol. So here we will see that the second symbol will be at phase shift of 3 pi by m with respect to the direction of cos 2 pi f naught t. So in this way, we will get all the m symbols. Here, all the symbols are having a mutual phase shift of 2 pi by m with respect to each other. And the distance of each symbol from the origin is given by root PSTS. Since the distance is same in case of all the symbols, we can say that these symbols can be represented on the circumference of the circle with the radius of root PSTS and a mutual phase shift of 2 pi by m radians. Now, here we can see the block diagram of the M-ary PSK transmitter. Here we can see that this is a sequence of message bits, which is in the form of 1 and 0. Now we know that here each symbol is made up of n bits. So this sequence of bits is given to serial to parallel converter. This serial to parallel converter will represent all the n bits parallelly after every time period Ts. Now, these combination of bits is given to digital to analog converter, which will convert this sequence of bits to some analog voltage. Now, whenever there is change in the bit combination, there will be change in the analog voltage MT. Now, this is a phase modulator. In this phase modulator, we have two inputs. One is this analog voltage MT and another is the sinusoidal carrier of frequency F0. Now, this phase modulator will modulate the phase of the carrier signal according to the incoming message signal MT. So, whenever there is change in the combination of bits, there will be change in the MT and here we will have change in the phase of the carrier signal. So here we will get M combinations. So M values of voltage MT and M-ary PSK signal for each bit combination. So this is how we will get M-ary PSK signal. Now, this is the block diagram for M-ary PSK receiver. Here, the demodulation method which is used is synchronous demodulation method. Now, in synchronous demodulation method, the synchronous carrier signal which is used at the transmitter is again generated at the receiver. Now, for generating the synchronous carrier, we will use the carrier recovery circuit, which is made up of 3 blocks. Now, in first block, the incoming PSK signal is first raised to power n. Then it will be given to bandpass filter, which is having cutoff frequency MF0. That means only those terms of sine and cos will be selected, which will have frequency of MF0. All other terms will be rejected by this bandpass filter. Now, this output will be given to the frequency divider, which will divide the frequency of all the signals by M. That means the incoming signals are having frequency of MF0. Whenever it is given to the frequency divider, the frequencies will be divided by M and we will get only signal cos or sine with frequency F0. So here we will see that we are having 2 carriers, cos 2 pi F0 t and sine 2 pi F0 t. Now, these 2 carriers will be multiplied by the incoming PSK signal and we will get ST into cos 2 pi F0 t and ST into sine 2 pi F0 t. Now, this block represents integrator and dump receiver. Now, this integrator and dump receiver circuit will integrate these incoming voltage signals over a symbol period Ts, which is given as NTB. Now, here, whenever these 2 signals are given to the 2 integrator and dump receivers, we will get for upper receiver as TSPE and TSP0. Here, PE represents all the even number of bits and TSP0 will correspond to odd number of bits. Now, these even and odd will alternately be combined and will be given to analog to digital converter. Now, this analog to digital converter will generate digital output corresponding to these analog voltage. Now, whenever we get a combination of n bits, it will be given to parallel to serial converter, which will generate a bit sequence BT. Now, whenever there is a change in the analog voltage, there will be change in the bit combination and bit sequence BT will be different for every PSK signal. So this is how we will again regenerate the bit sequence at the receiver side of the M-ary PSK receiver. Now, this is all for today's lecture. Thank you.